WMPG thrives with support from listeners and from Maine Solar Solutions. Maine Solar Solutions helping empower homeowners and businesses with solar electric solutions for 10 years. Information at mainsolarsolutions.com.
You're listening to WPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me, as always, is Bernie Rhyme, DJ Starwatcher. How are you, Bernie?
Yes, hi, Sarah. Very good. Thank you.
Bernie is our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPGScientificallySpeaking@gmail.com or on Twitter at WMPGSciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly. I'm glad you asked. So this will be Friday, July 1st, kicking off the big July 4th weekend here. And our topic will be fireworks, so that's perfect. Okay, so the moon will be waxing crescent. It was new on June 28th. So it'll be at the best phase to see the moon. You have a nice little waxing crescent. It's up for a couple hours and it sets after the sun, and then you can see other stuff in the sky. The days are still very long. We're already 9 days into summer, but the days are still long, almost 15 and a half hours, a little bit less. We're losing a couple minutes in the morning because the sun is rising later, but it's still setting at the same time, 8:26. So that takes about 2 weeks for that to switch, and the opposite happens 2 weeks before the solstice, winter and summer solstices. So that's kind of interesting. Basically, that great alignment we talked about last time, that's pretty much breaking up because Mercury disappeared and Saturn now comes up early by 11 and it won't be up anymore at that point. But you can still see 4 of the planets, so that's good. I mean, you'll still be able to see Saturn. So you can see that. So the moon comes up around 7, being a waxing crescent, 7 in the morning, so just a couple hours after the sun. No real meteors yet, but July, there's some meteor showers coming up. So you can look from some early Delta Aquariids and that type of thing. And even stray meteors, if you're out long enough, if it's dark enough, you could see 3 or 4 just stray meteors, even without the big showers that'll be coming up in a few more weeks. So that's basically it for this week. Not as exciting as last week, but still good. Fireworks will be good.
Yeah, something else to light up the night
Yeah, right.
skies.
Yeah.
Although they do probably take away from our ability to see the night
Yeah,
sky.
well, right, but they only last like half an hour or whatever. And then
Well,
we
we'll
get,
talk about that.
yeah, right.
Awesome. Thank you, Bernie.
You're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So welcome to another episode of Scientifically Speaking here on WMPG 90.9. I was going to say WMPG.org, but I guess you could be listening there as well. But 90.9 is what you're listening to. And as Bernie mentioned, our show today is very timely. We are going to talk about fireworks. We're going to talk about how they're made, a little bit of history, some of the chemistry behind fireworks, how they work, and then we'll kind of go into some of the environmental and health aspects of having millions of fireworks released into the sky for various reasons, various festivals, everything you can imagine for that's celebratory. So let's start with a little bit of history of fireworks because we know that they have a very long history. They've been around for a very long time. And is it fireworks itself, or is it the precursor to fireworks, if you will,
Well,
like
actually, the
gunpowder?
precursor goes back before BC. In China, of course, it all kind of started in China. So
Hmm.
about 200 BC, this might have even been like kind of by accident, but someone tossed some green bamboo into fire, and they saw that it would explode because the gas would become superheated inside
Hmm.
some of the cells in the green bamboo, and it exploded. So it was like a little firework type thing. This is way before gunpowder was even
Yeah.
invented, of course. And now, of course, we don't use green bamboo to make the shells and that type of thing. So around 900 AD, so maybe another 1,000 years after that accidental discovery, you had your Chinese alchemists who actually came up with the fire drug, basically gunpowder. They called it Hu Yao, so this fire drug. the gunpowder, and then of course they were making some form of a firework. Basically, the principles are still the same, but it's so much more high tech and interesting now, and I'm sure it didn't have all the colors. So then, by about 1400 AD, so about 600 years ago, they were getting much more artistic with them, and they were using, better qualities black powder. And during the Renaissance time in Italy, they were exporting all this all over Europe, and then fireworks became really popular just over 600 years ago.
Mm.
So yeah, so it's pretty long history, like a couple thousand years, but maybe 600 years at the level where they knew some of the colors and some of the chemistry involved and so on.
Yeah, yeah. Speaking of the
Hmm.
colors,
Yeah.
I think that's like one of the questions that we hope to answer today is
Hmm.
how do fireworks produce, or how are there so many colors produced from
Yeah.
fireworks? And, we see the standard ones, there's white ones, there's red,
Yeah.
there's blues and greens and oranges. What
Yeah.
chemicals are we talking about when we
Yes. So
talk
I'll
about
give you all the
fireworks?
details. I just learned about this myself.
All the details.
All the details, well, not in huge amount, of course. We keep this half-hour show, and I'm not a chemist. But it is very interesting. I used to watch some fireworks with a friend of mine that taught chemistry at a community college, and he was giving me some of the chemicals for like blue and green and stuff. But there's a lot more to it, and it's very interesting. Blue, by the way, is the toughest one to create just right.
Mm,
So when you see blue, you're going to appreciate that a little bit more than just a red one or a white one or
hmm.
something. Okay, so white or silver is caused by a whole bunch of chemicals. These are basically metal and metal salts,
Hmm.
but they have to be mixed properly, and then we'll talk about how we put them all together and that type of thing. So white or silver is caused by aluminum, magnesium, titanium, or beryllium. And
Mm.
beryllium is interesting. That's the fourth element, and the mirror for the James Webb Space Telescope is made out of beryllium and
Mm.
then gold coated, so the infrared it picks up. And of course, you
Nice.
probably heard a micrometeorite hit one of those meteors, hit one of those mirrors, but it's really not going to degrade the quality. I mean, I watched a whole video and that's going to be fine. What the problem somewhat is that they're hoping there's not too many at that L2 point, because they will drift in there and then they'll drift out. So it's not
Mm.
like they're not concentrating there, because otherwise it'd be more likely that some of the other segments of the mirrors will be hit. But that's beryllium, and that's what you use for white or silver. And then you have two types of red. So the pale red are created by lithium carbonates, and the stronger reds are created by strontium carbonates.
Mm.
So there's layers there. And of course, you can make them change colors as you go, and you can get really intricate. You can make 8 layers and all kinds of things. So yellow is pretty simple. Those are sodium compounds, actually similar to just table salt. Later on, we'll tell you how you can make your own little firework. Then gold is charcoal lamp black or iron, which is kind of interesting because gold kind of close to yellow is not really using sodium compounds. Then orange is made by calcium chloride.
Hmm.
The vibrant blue is copper chlorides, and again, that's the toughest one. I guess you have to do it just right. You can't overdo or underdo any of this stuff, or it won't work. And purple is interesting because it kind of makes sense. It's a blend of the copper chlorides for blue and the strontium carbonates for red. So basically, like blue and red. And then
Yeah.
you can almost get into the color wheels and the complementary colors if you do watercolor or painting and stuff, which I do some of that too. And you can see how that works, and you can create really artistic and
Yeah.
creative things with your fireworks. And then green, I had a little more trouble finding green, but green is caused by barium nitrates.
Yep. Yep.
So that's pretty much it for the colors.
I think one element I think it can also be used for purple is lithium. It's kind of like
Okay.
a
I
lavender
saw
color.
lithium under pale reds, but yeah.
Well, I guess, some of these they cross over red, purple.
Yeah.
And
Yeah.
then what's interesting about the blue
Hmm.
is I saw multiple sources say,
Hmm.
just like you, like copper is used for
Yeah.
blue.
Yeah.
In the past, arsenic was used for blue, and it was like a very strong blue. They don't use it now,
Oh,
obviously, because
arsenic.
it's
You don't want a lot of that
dangerous.
floating around. It pollute all
Exactly.
the wells in the area.
Exactly.
Yeah.
So that, obviously went out of style for
Hmm.
modern
I hope so.
fireworks. But what's interesting is that copper, when I have seen it burned, it looks
Hmm.
green to me. It doesn't really look blue. So I wonder if it's kind of on the cusp of like green and blue, and maybe, I don't
Hmm.
know, there's different concentrations
Yeah,
that make it
maybe
look more or
the
less.
way they put it together. Again, it's a copper chloride and then all the things. I mean, all the
Hmm.
actual ingredients are kind of top secret of all the different companies that make them.
Yep.
There's a lot of things. I mean, basic chemistry, of course, but then how you actually do it and how you arrange them and how you create all the shapes.
Yep.
So yeah, copper might be kind of greenish, but it creates the blues. So yeah.
Yeah. And then a little bit more about the chemistry. If you
Hmm.
think back to, your electrons and all of the different, I guess, electron shells, if you will. Um, what's happening is the colors are actually being produced by energy being released when excited electrons fall back down to their kind of standard state, if you will. And so what we're seeing is that you're lighting these salts up. You're injecting kind of energy into these atoms, and then the outermost electrons are being kind of pushed out, if you will. They're being ejected out into a further out shell, and then they'll eventually fall back down, and that releases energy in the form of luminescence or light. And so each of these different salts, which is why you have different salts to produce different colors, because different energies will are required in order to excite those electrons of these different salts.
Hmm.
Um, and yeah, I think that's kind of the gist of the chemistry behind the colors. And this actually segues really nicely because, as I mentioned, Bernie is our professor of the astronomy lab here at USM, and one of your labs is actually all about the electromagnetic spectrum
Yeah.
and the colors that different chemicals produce.
Well, actually, we do six. We have tubes of six different gases,
Hmm.
so we don't do like some of the salts and things. We
Yeah,
just do
but
an
it's the
actual
same idea. It is the
gases of
same idea.
elements. Oh, it's same idea. It's quantum mechanics that
Hmm.
creates those
Hmm.
spectrals based on the electrons, like you were saying. So that's kind
Yep.
of neat. So we have hydrogen, we have helium, we have mercury, and then we have krypton, and I think another one that we
Yep.
use.
Yeah,
Yeah,
but no, that the word that you used reminded me of
yeah,
exactly what we're talking about is the spectral lines, and
yeah.
this goes back into our Harvard observers, our Harvard computers,
Mhm,
and all the spectral lines. And so basically, each element has
mhm,
a set of different spectral lines
mhm.
that produce a color, and that's actually how astronomers figure out what distant stars are made of.
Yep, what stars are made of, and in what atmospheres of other planets might be made of, or even, things on the Earth. You can buy these million-dollar machines that do spectral analysis of different things right here. They're not just used for astronomy, of course, and they can get really complicated how you heat things up and see what's in them, all the little graphs and this peaks at all the different elements. So yeah, it's really interesting how that works.
Yeah, yeah.
Yeah.
It's all connected. And
Yeah.
again, the chemistry is pretty, I mean, it's complex, but it's also very basic in a sense.
Yeah, and it's
Uh,
predictable. I mean, if you make,
Yep,
you know exactly how they're going to turn out. It won't be a big surprise
yep,
unless, it doesn't explode or whatever, and then something else
right,
happens. But
right.
you create it the way you want to on purpose. It's very predictable. You have all the laws of chemistry, of course, laws of physics are at work, quantum mechanics are at work because the electrons, like you mentioned, mass is at work, all kinds of laws. You're just seeing all this at work in a very artistic fashion
Right.
once you create it. And most of them are still handmade. 95% of all the fireworks are completely handmade because they're so
Hmm.
dangerous. You got to make them just right.
Yeah, and before we go on to how they actually work, I did have. So, for those of you who want to actually experiment, there's actually a really simple way that you can kind of see some of these colors, not all of them, because you can't easily access all of the chemicals. But what we do have access to are table salt, which is made of sodium chloride. And we also have access to copper sulfate. Apparently, I didn't know this, but copper sulfate is available at kind of pet stores or aquarium stores, and it's actually commonly used to fight algae, I guess, production in your aquarium. Or I think you can also find it in hardware stores as like a root killer. And so it comes in kind of powder or like small crystals. So a really easy kind of experiment you could do is take a kebab bamboo skewer. You can put some glue on the top like inch of it, as if you were gonna I guess stab it into some glue and basically like roll that glue in some of the salt and, take another skewer and roll it in some of the copper sulfate. And basically what you would do is you would burn them and, do it outside. Don't breathe the fumes. Do it with an adult. Be safe about it. But you should be able to see the colors come out there. So that's like kind of a really easy way to see it in
Yeah.
action.
Yeah, because if you just buy sparkler, they're usually just white. You're not going to see any colors and stuff.
Right.
And
Right.
you didn't create any
Yeah. Yeah.
stuff.
Hmm.
Yeah.
Hmm.
Yeah, so that's neat. I didn't know that either till you had mentioned it earlier. So definitely, I should try that.
Yeah. All right. So we talked a little. We went over kind of all the chemistry of fireworks. Now, how do they actually work?
Mm-hmm. Okay.
Um, oh, go ahead, Bernie.
Well, I just watch a few short videos, and I encourage any of our listeners to watch some videos, like just 5 minutes or whatever. They're
Yeah.
really interesting. I knew they were dangerous,
Mhm.
but they any well, you hear once in a while the whole
Yeah.
plant will blow up or something. So
Yeah.
the workers, they have to wear anti-static gloves. They have all these things. They have to ground themselves every few minutes. So obviously, you probably can't wear any shoes, and there's no carpets in there, so you don't create any static when you make these things. And there's this one plant in China that makes fireworks for like all kinds of things, including the Asian Games and the Olympics. And there's only like one room, they're all like isolated rooms, and they have giant berms behind them. Only one person can be in each room in case something does happen. Only one person gets hurt, but still, at least better than having everyone working there. And you can never use more than 5 kilograms of the gunpowder at once. You have to make that firework complete, and then you move on to the next one. So there's not too much of it in the same place. So it's all, super regulated and important. And I think they've been pretty safe there. But yeah, the only thing that now has been automated is some of the taping.
Mm.
So, or gluing when you take the shells. It can either be a shell, a cylinder, or it can be a round shell.
Yep.
And you arrange the other things are called stars. And
Yep.
that's where you mix all the chemicals in. It just happen to be in the shape of a star, which is kind of clever. And you pour in like a few hundred of these, or however big you want the firework to be. It might be 50 of them or 20 of them. Certainly not the little thing that you can buy on the market here. So and it can be pretty big, and then you have a big fuse that you light, and that launches it up about 1,000 feet in the air. I didn't know how high
Mm-hmm.
these things go
Mm-hmm.
because they're so dangerous. If they only go a couple hundred feet, people are in big trouble. So it launches them 1,000 feet in the air because you can hear that has a great sound, and then they come out in all the different colors and shapes, and they can be really intricate, or they can just be one color. So if you want at this point, I can tell you what some of the shapes are called.
Yeah. Yeah.
Okay, so this is kind of neat because I've seen them and I always compared them to flowers. But these are the four most common ones. And if you see the video of this, the background Sarah has basically a shape called chrysanthemum. But there's four types of shapes. So one is called a peony, and it doesn't really have any trailers. It just sparks and they're there in nice colors for a few seconds. So that's the peony. And then the most popular one is the chrysanthemum, which has nice long trails coming off of it. And you can have multicolors the way you stack the little stars inside the shell. And you can have up to 8 layers for these. And the trail, the chrysanthemums are really very common. And then you have one called willow,
Mm.
which is much softer trail. So instead of a flower, now you have a tree. So it kind of trails off in a softer way. So that's the willow, still a nature thing. And the fourth really popular one is called cake, and it just takes on some strange shapes as it comes out. A lot of those you'll see at the end near the grand finale. So I don't know why it's called cake. It doesn't look like a cake to me. It still looks like some version of some of the natural shapes, but it's called cake for whatever reason. And those are your four most common shapes. There might be 10 or 12 more, like snowflakes. There's like 100 types of snowflakes or whatever.
Yep. Yep. Yep.
There's probably, yeah. So those four,
Yeah.
most of it, 95% will be those four shapes. So look for that
Yep.
and be aware of the flowers and what they're called.
Yep. What's also interesting is within those shapes, I think that they're pretty common now, but when they first came out, I was like, "Whoa, how'd they do that?"
Yeah.
Like smiley faces and hearts,
Oh, yeah.
some more complex shapes, and I don't think we have the ability to explain even more complex displays, but at the very least, you can see like smiley faces. They do actually arrange them in that shape within the shell, and so they actually do kind of explode where they are in the shell, if that makes sense.
Yeah.
So that's kind of a neat little tidbit too. And just going back a little bit when you're talking about how high they go,
Hmm.
there's kind of like these three compartments, if you will, right? You talked about where the stars are. That's your actual what you see,
Yeah,
and then you talked about where you light it to actually send it upwards, the
fuse. Yeah.
thrust part. Yep.
Hmm.
And then there is actually also kind of like a time delay
Yeah.
that will slowly burn into the interior, and yeah, that so like you said, they don't just
Yeah.
explode right there on the
Yeah.
ground.
Yeah, and
They're
you got to make them right because if you
Yep.
pack them too tight, it'll prevent that. If you pack them too loose, then the time delay won't work. Then everything will just go at once. And if you pack them too tight, it'll go and it'll stop. So
Yep.
there's a lot of skill involved, and that's probably one reason they're pretty much all handmade still.
Yeah, yeah, yeah. Um, and just a word of caution, we have seen many of these fireworks being kind of cut open to view a cross section, but don't do that. It's
Don't
actually
cut them
very
open.
dangerous.
Yeah, if you have any static, it can blow up. That's why
Yep,
the
yep.
people that make them are so super careful.
Yes, and
Yeah.
as a warning, I could not find any recent stats, but back in 2014, there were about 11 deaths due to fireworks and over 10,000 injuries. So they really can, they are pyrotechnics and they are dangerous. So
Yeah.
just a warning of caution to our listeners.
Yeah.
View from afar.
Yeah. Like when you look at the sun, always look at it safely with the right filters. We in
Yeah.
astronomy, we always do that too. So yeah.
Can I ask you a question? Because I
Sure.
woke up and saw the sunrise today.
Yep.
Um, since you mentioned the sun,
Yeah.
can you look at the sun
Mm.
at sunrise and sunset? Is that different versus looking at
Yeah.
it up high in the sky?
Oh, it's very different. And if even if well, if you have a few clouds, I've looked at the sun for as long as like almost an hour if it had enough clouds after
Hmm.
it came up. If there's no clouds, you can probably just do it for less than a minute. But
Okay.
no, even in general, and the whole reason it's red when it rises and sets, you're looking through a thicker part of the atmosphere.
Right.
So that's acting like a nice lens and making it a little bit safer. But
Yeah.
if there's not a single cloud anywhere, even when I watched the full moon come up the other night, there were some clouds. But if there's no clouds, then don't look at the sun even half a minute after it came up anymore.
Yeah.
But it should be a lot safer than looking at it when it's directly overhead, then you have almost no atmosphere. You have less atmosphere between you and the sun.
Awesome. Your
Yeah.
daily dose of astronomical OSHA
Yeah,
safety
right.
rules.
Safety for right. Yeah.
And so, speaking of concerns and safety and environmental concerns, health concerns, fireworks have become very, very abundant over the last 20, 30, 50 years. I don't know. And we're coming up on to many fireworks in a couple days. And fireworks do actually have some environmental and health concerns. So during an explosion, as we've talked about, the copper chlorides and the sulfates, all those are all metal salts, and these don't necessarily like burn up. They don't go away. They are still metal atoms, and many of them do end up as aerosols, basically small particles that do poison the air. They can get in the water and they can get into the soil. And obviously, if you're very close, if you inhale it or ingest it, they can cause some, reactions. For some people, you could vomit, you could have diarrhea, you could have some asthma attacks. And if you're kind of constantly ingesting these types of metals, you could, there could be some kind of long-term chronic diseases. So it's not all kind of beautiful, just beautiful. There are potentially some risks involved. And so the most obvious kind of issue of a fireworks show is air pollution. We see it when, after the lights go away, there's this huge cloud of smoke.
Smoke that lasts for a long
Yeah.
time.
Oh yeah, very long time. And
Yeah.
actually during, I believe in 2019, there was, I guess you could kind of do this anywhere, but the emissions were measured after a Diwali festival in India, where they also have a lot of fireworks.
Mhm.
And they measured the air quality index, and it essentially like maxed out the charts of,
Mm.
the scale of the air quality index
Mhm.
scale, if you will. And and so basically it's like a very poor air quality. And, as we mentioned, it adds kind of dangerous gases and aerosols to the atmosphere. And it can increase kind of nitric oxide, sulfur dioxide, which contribute to acid rain, which is what we see in heavily industrialized areas. Um, Airborne particulates, the gaseous pollutants, and these metallic emissions can actually also stay in the air for quite some time. And so that's kind of another concern. And you'll often see kind of elevated mass concentration of fine particulates of those elements, so strontium, magnesium, potassium, barium. And what one study actually found is with 1 hour of fireworks, strontium levels in the air can increase 120 times, magnesium 22 times, barium 12 times, potassium 11 times, and copper 6 times more than already present in the air before the event. And these pollutants can actually also travel far from where the fireworks happened. And so in kind of mild weather, these types of heavy metals can actually travel over 62 miles, very specific. I think it was 100
100
kilometers.
kilometers. Yeah.
Yeah, downwind over kind of a 2-day period, and so they can spread out through other areas of the region. And because if it rains, it can then pollute local watersheds as well.
Mm.
So there's a lot of concerns as far as some of these environmental impacts, some of our health impacts as well. But some positive things is over the past many years, probably several years, there have been some uh, advancements in technologies to kind of reduce the impact of a lot of it. And specifically, they tried to develop like chlorine free compositions, for example, using like copper iodide instead of copper chloride, and using kind of higher nitrogen based materials instead of basically other heavier elements. And those basically can burn more cleanly and also produce less smoke or less soot as well. For barium compounds, which produces the green, they have tried to kind of replace those with boron, which also apparently produces kind of a green color. So I think the big one is probably trying to reduce some of the chlorines. Another big one is removing kind of perchlorate oxidizers, which are also, I guess, very bad.
Mm.
But yeah, there are some advancements trying to create not only smokeless or cleaner burning fireworks, but there are also some advancements in trying to create quieter fireworks because
Mm.
that's, you know, there's dogs who can't handle it, children.
Car alarms go off all the time.
Yeah.
There's a whole parking lot
Yeah.
full of car alarms.
Exactly, exactly. So, yeah, lots of really cool things going on in the fireworks space that I
Mhm.
don't think we ever realized.
Mm.
And now we know, what makes all these colors. And even though we know that there's some environmental concerns, it's
Mhm.
not like they're going off every single day. I guess some places like the Sea Dogs, they do
Oh, they're
fireworks
probably every day.
once a week or some, yeah, every day.
Old
Probably
Orchard Beach doing
Disney.
it every week in the summer. Old Orchard Beach has them.
Yeah.
Yeah.
Well, I'll take that back then.
Okay.
But Bernie, what should listeners kind of think about as they're watching the fireworks over the next few days?
Well, I mean, they are basically chemistry and physics in action, so that's kind of neat, knowing everything, even quantum mechanics, just how the electron shell levels work. They're very creative and artistic. Um, Obviously, they're a lot safer than like bombs, and the other aspect of it will be just to destroy things. These are more to create things, and there'll be a little bit of pollution, But basically, if you have good airflow, and they do go 1,000 feet up, and you get the nice shapes like we talked about, the chrysanthemums and the willows and everything. They're so much safer and creative and artistic. And there's, they celebrate and you learn something about chemistry, physics, math, all kinds of things. So
Oh,
those are some of the positive sides of fireworks.
yeah, absolutely. Now
Yeah,
you know all the colors.
yeah, yeah. They're not bombs. Not bombs, so that's good.
Awesome. Well, you have been listening to Scientifically Speaking here on WMPG with myself and Bernie. Stay tuned for Something for the Weekend with Anella. And from your favorite nerds, just a reminder to keep trying to vaccinate to mitigate. And I guess we're already congregating, so
Yeah.
just be vigilant.
Yeah.